Deep learning is fundamentally about teaching computers to recognize patterns in data. It's about enabling machines to discern and understand complex relationships without explicit programming. Think of it like showing a machine thousands of cat photos until it learns through repeated exposure what a cat looks like, its defining features, and how to differentiate it from other animals. PyTorch is the open-source library that makes this possible. It gives us the essential building blocks for creating these learning machines, which are more formally called neural networks. These networks are the core of most modern deep learning systems. Developed by Facebook's AI research lab, now Meta AI, PyTorch has gained immense popularity for its flexibility, its intuitive design, and its Pythonic nature, making it a favorite among researchers and developers alike. If you already know Python, PyTorch will feel remarkably natural and easy to pick up, letting you build complex models with clean, readable, and maintainable code. This ease of use is a key advantage. It's a framework powerful enough to handle massive datasets and build the most advanced AI models, yet surprisingly simple to get started with, even for beginners. To install PyTorch, the best approach is to visit the official PyTorch website. There, you'll find a command tailored specifically to your hardware configuration and operating system. For most users, a simple command is all you need to get up and running. However, if you have an NVIDIA GPU in your system, be sure to use the CUDA-specific installation command to leverage its power for significantly faster model training. And if you're working on the cutting edge with Apple Silicon Macs, PyTorch seamlessly utilizes metal performance shaders for GPU acceleration, ultimately making high-performance deep learning more accessible and democratized for everyone, regardless of their hardware. The core data structure in PyTorch, the foundation upon which everything else is built, is the tensor. It's a multi-dimensional array, a versatile container that can hold numerical data. Think of it as a generalization of scalars, vectors, which are one-dimensional arrays, and matrices, which are two-dimensional arrays. You can easily create a tensor from a Python list, making it simple to bring your existing data into the PyTorch ecosystem. Tensors are designed to support fast mathematical operations, crucial for the heavy computations in deep learning. These operations are optimized for both CPUs and GPUs, allowing you to leverage the power of parallel processing for even faster computations. This is how we represent and transform data, turning raw information into a format that our models can understand. Like images, where each pixel is represented by a numerical value, or text, where words are converted into numerical embeddings. This data then flows through neural networks, complex structures designed to learn patterns and relationships. Neural networks learn by adjusting parameters, tiny knobs and dials that control the network's behavior to minimize error. This process requires calculating gradients, which indicate the direction and magnitude of the steepest increase in error. PyTorch automates this crucial step with a dynamic computation graph, building a map of all the operations performed on your tensors. This graph meticulously tracks every operation, allowing PyTorch to understand how each parameter affects the final output. Its autograd engine then steps in, computing gradients automatically, saving you from the tedious and error-prone task of manual differentiation. All it takes is a simple call on your loss, triggering the backward pass that calculates all the necessary gradients. This elegant system lets you focus on designing your network, experimenting with different architectures and layers. You can unleash your creativity while PyTorch handles the complex calculus under the hood. With tensors and automatic gradients, the two pillars of PyTorch, you have the fundamental tools and the freedom to explore the exciting world of deep learning model development. Now let's dive into the practical side and build your very first neural network using PyTorch. We'll walk through the fundamental steps, providing a clear and concise guide to get you started with deep learning. The first step is to define your model. In PyTorch, this is done by creating a Python class. This class will encapsulate the architecture and behavior of your neural network. This class will be inheriting from the specifying the layers that make up your network in the constructor, and defining the data flow in the forward method. This method dictates how the input data passes through the network's layers to produce an output. PyTorch provides a rich set of pre-built layers like convolutional layers or recurrent layers, which are modular and easy to stack, allowing you to create complex architectures with ease. One of the key features of PyTorch is its dynamic graph, which allows for flexible model architectures, making debugging and experimentation much easier. You can define complex control flow within your model using standard Python control flow statements. For managing your data, Use the class to organize your samples and corresponding labels, and implement the and methods. To streamline the data loading process, wrap your dataset in A. This handles batching, shuffling, and parallel data loading, optimizing your training pipeline. The efficiently feeds data to your model so you can focus on training logic and model development. With these powerful tools, you can quickly prototype and train neural networks, accelerating your deep learning journey. PyTorch's modularity and efficient data handling make it an ideal framework for both beginners and advanced users tackling complex research problems. Now that we've covered the basics, let's delve into how to train and evaluate your model effectively. Training happens in a loop, a fundamental process in machine learning. For each batch of data, run a forward pass through the network, and then compute the loss, followed by clearing the gradients, then backpropagate the loss, and finally, update the model's parameters. Evaluate your model's performance on unseen data by switching to evaluation mode, with and using for efficiency and to save memory. Save your model's learned parameters periodically with, reload them later when needed with. To significantly accelerate training, use a GPU set your device and move both your model and data to it. For example, then, for large-scale projects and complex models, PyTorch supports distributed training seamlessly across multiple GPUs. This workflow, from tensors to multi-GPU training, clearly showcases PyTorch's power and its inherent simplicity. With just a few lines of well-structured code, you can build, train, rigorously evaluate, and effectively scale deep learning models. PyTorch truly makes advanced AI development accessible to everyone.